Okay, today we're going to cover 6.1, exponential growth and decay functions. Consider the exponential functions f of x equals 2 to the x. So, for example, you have a function value f of negative 3.1 equals 2 to 3.1. So, when you put in the calculator, graphing calculator, you put 2 and the arrow, this arrow, open parenthesis, negative sign, and 3.1, close parenthesis, enter. So it will gives you 0.1166291,239. So you can round it up to 7 decimal places or 2 decimal places. You could round it up for 7 decimal places as 0.1166291. You round it up to 2 decimal places would be 0.12. Okay, here's another example. F of 2/3 equals 2 to the 2/3 power. So we'll put in 2, so clear this one, 2, arrow, open parenthesis, 2 divided by 3, close parenthesis, enter. And it will give you 1.5874011. You round it up, this is 1.587401052. So round it off. The 0 will become 1 over here. So 1.5874011. Exploration. Number 1. Identifying graphs of exponential functions. Okay, you can work with a partner, or you can work by yourself. Match each exponential function with its graph. Use a table of values to sketch the graph of the function if necessary. So if you put it in the graphing calculator, we'll see. But we clear this out. Y equals, then I have in something here. There it is. So 2 to the x. So we'll put 2 arrow in x. Let's graph. How does the graph look like? So it looks like the letter A. Okay, it's going up. It touches the 0, 1. Then it goes up here. So it looks like letter A. So 2 to the x is letter A. Okay, we'll do f of x equals 3 to the x. Let's say 3 to the x. Okay, go back to y plus 1, and then we clear this. Put 3 arrow x and graph. So that looks like letter F here. So the 3 to the x is, the graph is letter F. Now let's see, f of x equals 4 to the x. So you got here, and then clear this, 4 arrow x and graph. That looks like letter C. Okay. So the C letter C is matched with letter C. And letter D, f of x equals 1/2 to the x power. So, clear this. So, we just have to put it 1 divided by 2. Put parentheses on it. And then 1/2 arrow x. We can enter and graph. So that matches with letter D. Okay, letter E. Okay. We could blur, and letter D is 1/3 to the x power. So open parenthesis 1 divided by 3, close parenthesis, power to the x. Enter and graph. Okay, that's looks like letter B. So that matches with letter B. Now the last one is 1/4 to the x power. So there it is. Open parenthesis 1 divided by 4, close parenthesis, arrow, power to the x. Enter and graph. And of course, the last one is letter E. Where's letter E? Okay. For number 2, exploration, characteristics of graphs of exponential functions. So use the graph in exploration 1 to determine the domain, range, and y-intercept of the graph of f of x equals b to the x, where b is a positive real number other than 1. Explain your reasoning. Okay, so number 2 would be the domain is all real numbers, and the range would be y is greater than 0. Okay. So the domain are all real numbers. It's negative to the infinity, positive to the infinity, and the range is greater than 0. And the y-intercept is 1. Yeah. The y-intercept is 1. So the graph has no poles or stopping points. So it keeps going, but it doesn't go down the y to the negative y. It's barely touch 0. Barely touch the y equals 0. So our range is always greater than 0. So when x equals 0, f of 0 equals b to the 0 power will be equal to 1. So when x equals 0 here, our y equals 1. Number 3, what are some characteristics of the graph of an exponential function? Okay, the graph has the x-axis as an asymptote. So the x-axis is the asymptote here. That's what you call an asymptote. Asymptote. Letter B. So the x-axis would be the asymptotes. This is what you call asymptotes. Okay. There is no restriction on the domain. So the domain is all real numbers. On exploration 2, the fourth question. Is it possible for the graph of f of x equals b to the x to have an x-intercept? Explain your reasoning. Okay. There's no x-intercept because it's not gonna stop the x. It's not gonna touch it. So it's just barely touch it, but it won't be the minimum. It's keep going and keep going, but it will not touch the x-axis. So at the x-axis, at the x-intercept, the y value is 0. And 0 is not part of the range of an exponential functions. So the range would be always greater than 0, so it won't touch the 0. Alright,